Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem longest turbulent subarray. We're given an integer subarray and we want to return the length of the maximum size turbulent subarray from the given input array. Now, what exactly is a turbulent array? Well, it's best understood with an example. So let me first draw it out using this example that they gave us, and I'll show you how simple this problem really is. So let's say that this is our input subarray. For every adjacent pair of values, there's some equality between them. Either this one is going to be greater, which is true in this case, or we could have the opposite case where the right value is greater, or we could even have a third case where adjacent values are equal to each other. Every pair of values, every adjacent pair of values is going to have some equality between them. I'll quickly draw them out here. We can see 4 is greater than 2, 10 is greater than 7, 8 is greater than 7, 8 is greater than 1, and 9 is greater than 1. All we want to do is return the longest subarray, well, not the actual subarray itself, but the length of the subarray, such that we have the longest alternating streak between equality signs. What I mean by that is, no matter how we start, for example, here we start with a greater than sign, then for the rest of the sequence, the sign has to be alternating, like the equality has to be alternating. First it was greater than, now it's going to be less than, then it's going to be greater than, and then it's going to be less than. Now, for equal, we don't count that. So a turbulent array, as defined by this problem, is alternating between greater than or less than signs. One more point of clarification. Here we have 4 signs, but we're not counting the signs themselves. These signs form this array where we have 1, 2, 3, 4, 5 values, and we return 5. You can see that down here. So why couldn't we also include the first value over here? Well, take a look at the signs. We started with greater than, that's fine, but then we had a second greater than in a row. That's not what we were looking for. At that point, we can't include this anymore. This is the longest turbulent subarray, well, these first 2 values, where we can start at this value. So thinking about it this way, the problem becomes pretty simple. We're just looking at this array. We want to find that optimal longest turbulent array, which is this one in this case. We can't extend it further over here. Now, technically, this is also a turbulent array. It has 3 values in it, but that's not what we're looking for. We have a longer one, which is 5 over here. So how can we solve this problem efficiently? Because when we're talking about subarrays, we know we can brute force this by just checking every single subarray and do that in n squared time, because that's how many subarrays there are going to be. So how do we do even better? Well, when we get here, the first 2 values, we are good so far. It's sort of like a sliding window technique, or you could say this is pretty similar to Cadane's algorithm. I kind of think of them as overlapping because they're very similar. But yeah, sliding window, we're going to try to grow our window as much as we can. But when we can't grow it anymore, let's see if there's any patterns we can identify to eliminate any repeated work. Starting at these 2 guys, there's some equality between them. The only problem would be is if there was an equal between them. At that point, we would be able to say this is not even of length 2. But since there is equality between them, this is a valid turbulent subarray of length 2. But now when we introduce another value, at this point we would initialize our pointers like this, by the way. We'd have a left pointer and a right pointer for our sliding window, and then we would shift the right pointer over here. Now we're comparing these 2 values. We're always going to compare the value at index right with index right minus 1, which is over here. So now we look at this and we see that the problem here is that our previous one was a greater than, and right now, again, we have a greater than sign. That's not what we wanted. We can't say that this is a turbulent subarray. So what do we say? We found the longest one starting at this position, but now we have to start over. We're going to now start at the next position over here at this left index. And our right pointer, which was over here, is now going to be shifted to the right by 1. So now our right pointer is going to be over here. So now we keep track that the previous sign that we saw was a greater than sign, And now we compare right with index right minus 1. So we look at this equality sign. Now it's less than. Well, I don't even know. I think this one is called greater than, this one is called less than, but the point is that they're different. This is a valid turbulent subarray. Now we go one more time over here. We see again that they are opposites, so this is also a valid turbulent subarray. We go one more time. Our right pointer is over here. Compare these two, see the sign? It's the opposite, which is good, so these are continuing to be turbulent subarrays. Finally here though, and this is going to be interesting, we get the equality. So not only is it different than the previous one, but it is an equality sign, which we are going to handle in a special way. I'll show you how. The first thing is that this is not a turbulent subarray. So now what should we do? Should we now try to find the longest turbulent subarray starting at this position? We already found the longest one starting at this position. That's this guy of length 5. So now should we start over here? Well, definitely not, because if this whole thing is a turbulent subarray, then we know for sure, and we're not including like this rightmost value, but if this whole thing is a turbulent subarray, then for sure this is going to be a turbulent subarray. Because if all of these are alternating, then of course a subset of them are also going to be alternating. We're basically saying that for a turbulent subarray, any subarray of that turbulent subarray is also going to be turbulent. So that's why we can use the sliding window. At this point, I would take the left pointer and not just shift it by 1, but I would shift it all the way over here. Now, our right pointer is already here. I'm going to move the left pointer over here as well. And we're also going to shift the right pointer by 1 over here. So we would have this subarray, and it is turbulent because it's different than the previous value, which was, well, the previous equality, which was equals. This one is greater than. And at that point, our algorithm would continue as normal. Now, the one thing I want to say that's different about the equality here, what if instead of this being an equals, we just had another less than sign? Well, in that case, our right pointer is already over here, but we would actually want our left pointer from over here not to be shifted all the way over here, because then our left pointer would be here, and then we'd increment the right pointer to be over here, and then we would check this. But that would be a problem, because in that case, we would have missed this subarray. We would have just skipped all the way to here. So when there's an actual greater than or less than, in that case, we don't want to skip all the way to the right index. We don't want to take our left pointer and then shift it to the right index. We want to stop at right minus 1. So we would normally stop here if this is not an equal sign. But if this is an equal sign, then we don't shift the left pointer over here and the right pointer over here, because this is not even like a valid turbulent subarray. Even though it's just two values, it's not valid. So we would just want to skip this one altogether. But that's the main idea. It's basically a sliding window problem at its core. So the time complexity is big O of n. It's a linear time algorithm. And the space complexity is O of 1, because we don't need any additional data structures. So now let's code this up. So as I said, I'm going to first initialize my pointers, a left pointer to 0 and a right pointer to 1. I'm going to also initialize our result and the previous sign. So initially, I'm going to set the result, which is the length of the maximum size turbulent subarray, to be 1, because we're guaranteed that the input array is going to be non-empty, and a single value does count as a turbulent subarray. So I think 1 is a good initial value. And I'm going to set the previous sign equal to the empty string. It can also end up being the greater than sign or the less than sign, or just empty as well. I'll show you how that's going to be used in a bit. We're also going to take our right pointer and just iterate it through the entire length of the array. There's a couple cases. If array at index r is greater than the array at the previous index, or actually, I'm going to write it the other way. I'm going to write the smaller or the previous value to the left, because this is how we're going to use our equality signs. But if the previous value is greater and the previous sign was not equal to the greater sign, meaning that it was either empty, meaning that we basically started at the beginning of the array, or that it was the less than sign. This is good because that means our array is turbulent. So at that point, what we would do is possibly update our result. So we would set it to the max of itself and the length of the current subarray, which would be right minus left plus 1. We would also want to increment the right pointer by 1, and we should update the previous character now to be equal to greater than, because that is what we have here. So this is just one of the cases. With my solution, there is going to be some code duplication. I could write it a more concise way, but I think the way I'm going to write it now is going to be very clear on what the solution is. Because we have these equalities, I think this code is going to be really easy to read, and it's going to be pretty easy to write as well, because this was one of the cases. Now I'm going to just copy and paste this and get the other case. Else if we had the opposite of this, meaning if the current value is greater and the previous sign was not the greater sign, or whatever you call this, then we would basically do the same thing here. The only difference is we would change the previous character to be the opposite one. And the third case here is either we had consecutive signs or we saw an equal sign. In either case, we want to set the previous to be something else. We could set it to be equal, or we could just set it to be like an empty string. It doesn't really make a difference because the way we're actually using it here is we're only checking if it's not equal to this or not equal to this. So we can just keep it simple here. The other case is, remember the right pointer, if they were equal signs that we saw, or if the two adjacent values were equal, then we want to increment our right pointer. So if array of at right index is equal to array at right minus 1, then we want to set right to right plus 1. Else we leave it as it is. And regardless of how we update these, we always want the left pointer to be equal to right minus 1 if we are updating our sliding window, if this condition executed. This part, I admit, is probably the most confusing about this solution, but it has to do with how we want to handle equal signs. Basically, we want to skip them altogether. This is the entire code. You can see all we really have to do is keep track of the previous character. That's giving us all the information we need. The rest of it is pretty much just duplication. We're just updating previous 3 times. We are updating the result a few times and just incrementing our pointers a few times as well. After that's done, all we have to do is return the result, and let's run this to make sure that it works. And as you can see, yes, it does. It's pretty efficient. If this was helpful, please like and subscribe. If you're preparing for coding interviews, check out Leetcode.io. It has a ton of free resources to help you prepare. Thanks for watching, and hopefully I'll see you pretty soon.